Today we'll be covering Lesson 2.5, Solving Literal Equations for a Variable. The first slide that you saw today, you should have unpacked the learning targets. The two learning targets that covered for today, solving literal equations for a specified variable and using a formula that has been solved for a specified variable to determine an unknown quantity. We've got 3 chunks for today's lesson. And to proceed the first chunk, you saw this paragraph along with this set of math terms. A formula describes how 2 or more quantities are related. Formulas are important in many disciplines: geometry, physics, economics, sports, and medicine are just a few examples of fields in which formulas are widely used. A formula is an example of a literal equation. A literal equation contains more than one variable. Literal equations and formulas can be solved for a specific variable using the same procedures as equations containing one variable. Math terms. A literal equation has more than one variable, and the equation can be solved for a specific variable. Formulas are examples of literal equations. A formula is an equation written using symbols that describe the relationship between different quantities. Our first chunk covers example A. They've worked through an entire example for us, so let's take a look at that. Example A says, solve the equation 4x plus b equals 12 for x. Step 1. Isolate the terms that contains x by subtracting b from both sides of the equation. So they started with the original, 4x plus b equals 12. Then they used the subtraction property of equality and subtracted b from both sides of the equation. Well, b minus b would cancel out, but b is not like with 12, so we would write that as 4x equals 12 minus b. Next thing we would do, isolate the x by dividing both sides by 4. So we're going to use the division property of equality. So we divide 4 on the left-hand side, and we divide 4 on the right-hand side. That leaves us with x equals 12 minus b divided by 4. Your other option is you could have done 12 divided by 4 is 3 and just wrote the b over 4 because the 12 over 4 does simplify. Here in the Try These A section, it gives us 3 different literal equations because they have more than one variable, and they've asked us to solve for a specific letter. So we're going to take a look at example A for the Try These A. I'm going to write these on a separate piece of paper just so we have some room. So I'm going to start with A, which states ax plus 7 equals 3. It asked us to solve for x. So the first thing we want to do is we want to isolate the term that contains the x. Well, the x is attached to this a. So I want to isolate that term, and to do that, we're going to use the subtraction property of equality and subtract 7 from both sides. Ax equals negative 4. Next, we're going to isolate the x by dividing both sides by a. Here I'm left with x equals negative 4 divided by a. So, whenever I solved the first equation for x, I got x equals negative 4 over a. Let's take a look at b. B says, Cx minus 10 equals negative 5. First step, isolate the term that contains the x. Well, my term is cx, so we're going to add 10 to both sides. That leaves me with cx equals 5. Now, isolate the x. Well, c is being multiplied to x, so to undo multiplication, we would do division. So we are going to divide by c. So x is equal to 5 over c. X equals 5 over c. Last thing we're going to look at is letter C. Let's take a moment. That was negative 3x plus d equals negative 9. Again, we are isolating the term with the x. So in order to isolate the term with the x, that means we need to move the d first. In order to move the d, we're going to subtract it. So I subtract d on both sides of my equation. Please notice the way I wrote this. I did not write it underneath the 9 because they are not like terms. That brings down negative 3x equals negative 9 minus d. Now we isolate the x itself. I divide by negative 3. I want to take this into parts. What is negative 9 divided by negative 3? A positive 3. What is negative d divided by a negative 3? Positive d over 3. So my final answer here would be x equals 3 plus d over 3. So that was x equals 3 plus d over 3. On to your debriefing questions.